JEE 2016 physics paper. We are going to start the solution of this chapter, this question paper one by one. So, first of all, I'll discuss question number 1 asked. It is just set number E and question number 31. This question is all about a combination of capacitor is set up as shown in the figure. The magnitude of electric field due to a point charge Q having a charge equal to sum of the charges on 4 microfarad capacitor, 9 microfarad capacitor at the point 32. So we have to find out the value of electric field due to a charge spread over the capacitor, seen over here in the diagram. So this question is just from the capacitor in electrostatic, and it's a very easy questions. So what we have to do in this question, this concept used, it is from electrostatic, basically from capacitor. Concept use, finding electric field at a distance r due to charge spread 4 pi epsilon into the distance r square in the free space. Now we have to find out the charge spread over 4 microfarad capacitor and 9 microfarad capacitor. So now we are given the diagram, we are given the circuit diagram like this. There is a 4 parallelly, we have 2 capacitor connected, and it is common with the 2 microfarad capacitor like that, and then finally connected to the battery, DC battery. The value is 8 volt, positive and negative. The value of this is 4 microfarad, and the value is just 2 microfarad, and the value is 3 microfarad, and the value is 9 microfarad. So we have to find out the value of charge spread over 4 microfarad and 9 microfarad. So mean if I am saying the value is Q1 over here and the value is Q2 over here, that Q1 plus Q2 will give me the value of K. How can we find out? How can we find out the value? So now we can see whenever we want to find out the net capacitance, means net charge distributions. So 8 volt battery, A and B, C and D are connected in parallel. That's why potential difference across AB will be same. Now the distribution of potential across this portion or along 4 microfarad will be equal to the potential drop across the combination of 3 microfarad and 9 microfarad. So we know that charge, because charge in series, so we can say charge over 4 microfarad will be equivalent to the combination of charge across 3 plus 9, because it is in parallel. So 3 plus 9, that is around 12 microfarad. So we can see the capacitor value is just 4 into the voltage drop. We let voltage drop is V1. That should be equal to charge 12 into V2. 12 is the value of capacitance, 12 microfarad into the value of V2. As we are assuming 12 V2, because we want to find out the charge across this one. Now net potential V1 plus V2, because V1 plus V2 should be equal to 8 volt. V1 plus V2 is equal to 8 volt. Solving this mathematical equation, finally we are getting the charge on 4 microfarad will be equal to the capacitance and the voltage across this CV1. Similarly, we want to find out the charge across 9 microfarad. It would be equal to the value of capacitance, that is given as 9 microfarad, into the potential drop across this, and it is just in parallel combination. So we will calculate V2, that is equal to CV2. Solving this, we will get net charge spread over, that is equal to 4 into 6, that is 24, plus 9 into 2, because 2 volt would be the potential drop, 9 into 2. So finally we are getting the value as 42 microcoulomb, and the value of electric field would be equal to Q upon 4 pi epsilon into R square, and Q is just 42 into 10 to the power minus, this is what, 42 coulomb. So 42 into 10 to the power minus 6 divided by this value R is just given as 30 meter. So square of this and 9 into 10 to the power 9. Solving this one, we will get the value around E is equal to 42 Newton per coulomb. Hence option 4 is correct. Now, after this, we would like to start a new one. Okay, in question 32. In question 32, we are given an observer looks at a distant tree of height 10 meter with a telescope of magnifying power of 20 to the observer of tree appears. Actually, this question is taken from the text where we discussed resolving power of telescope. Telescope is a device used to find the magnification, used to carry out the magnification of a distant object, and that can be calculated. Just magnification is equal to the linear distance upon that. So means height upon the lateral distance, we can say. Now it is given the magnifying power is actually 20 times and original land height is 10 meter. So we are comparing to observe the tree appears. So it is just a direct question, we can assume it whenever we want to see. Means if any object is just of 10 meter and we want to see this object from very large distance, so it will assume very smaller. But when we are watching it through the telescope or we are just scanning, so obviously telescope is used to magnify the power of this height 10 meter just 20 times because it is given magnifying power is 20. That's why the size would be 20 times taller than the original one. Okay, it appears to be. So option D is the correct choice. Now question 33. In question 33 we are given a hysteresis loop for two magnetic materials A and B are given. Now we are given four options. Now these materials are used to make magnets for the electric generator, transformation core, electromagnetic core, and we have to find out the proper which can be used. We must understand in hysteresis law we usually discuss two points: retentivity and coercitivity. Means residual magnetism or permanent magnetism in the case. So in the diagram A, we are getting the retentivity just remains for a long time first as compared to the graph given in B, because it is just magnetic field and intensity relationship. So we can say in this case for the electromagnets and transformer, because what we requires a core that can be magnetized and demagnetized. Means that can be magnetized and demagnetized. There should not be any residual magnetism for a long time. It means we can say the variations, or we can say retentivity should be of very low value and it can be observed for a very constant, that is between D and H. So we are getting this is for so we can say B for the electromagnets. Okay, means this is for the electromagnet. Okay, and we can say same for the transformer. Same for the transformers, because we don't want to put residual magnetism for a long time, and that's why we need retentivity for a short as compared to the graph given in for option A. Hence option 1 is the right choice. Now we would like to discuss question number 34. In question number 34 we are getting half-lives of two radioactive elements A and B are 20 minutes and 40 minutes respectively. Initially the sample have equal number of nuclei. After 80 minutes the ratio of decay numbers of A and B would be. So we are given, actually this question is taken from the radioactivity in the chapter modern physics. It's a very easy question. So we are given A and B. Half-life of A is equal to half-life of A, that is equal to 20 minutes, and half-life for B it is given as 40 minutes. So we want to know initially the sample had equal number of nuclei and not. Okay, now we would like to discuss here after 80 minutes, means after a duration of 80 minutes, after a duration of 80 minutes we want to find out the ratio of decayed number of A and B nuclei will be decayed. So we know that if there is an element at initial and not, after certain time, if it has a lifespan of T and half-life is T half, so amount of substance remain at any time T will be equal to N naught 1 by 2 T total time from T half. This is what time or amount or nuclei remains at after certain time T. So we want to find out decay. So decay can be calculated. Decay, that is equal to an initial minus this value and not 1 by 2 to the power T upon T half. Okay, so for the two cases, easily we can calculate for A. For A, that is equal to n naught 1 minus 1 by 2 to the power T. It is given 80 minute 80 by 20. So 80 by 20. Similarly, n for B, that is equal to n naught 1 minus 1 by 2. Okay, and its power is 80 by 40. Solving this value for NA and B, usually we will get the ratio that is around 4, 5 by 4, and hence option A is correct. So option first is correct. So we usually this question is based on radioactive directly, and it's an easy one. Now, next part we would like to discuss, and the next question is given: a particle of mass m is moving along the side of a square of side A with a uniform speed b in xy plane. Now we are given the graph. In this graph, this is in between y and x axis where the particle is tracking for A to B, B to C, C to D, D to A, and we have to find out the angular momentum. So now this is question number 35. In question number 35, we are given a particle of mass is moving along the side of this. So usually we can say this is y, this is x, and this is origin. Particle is going from D to A, D to A to B, B to C, C to A, over this way. So we are getting the R, it makes angle 45 degree with this. So this distance can be, if I am calling this distance, okay, so we can say this distance as R cos of 45, as length is A, it is a square, and this distance is also R sin 45. Now we have to find out angular momentum across LDA. Okay, so we know that angular momentum is what? Angular momentum is actually equal to radial distance multiply the vector product with the P. Okay, so we can easily calculate that is R into P sine of theta angle between them. Now the direction part. This particle is going along negative y-axis. Okay, so we can say its velocity, that is R into m into v, right? That is in sine theta. So usually we can say, or rather to put this value, we can just take sine. We will calculate it. Now R is just this distance. Okay, so we want to know when it is going from D to A. The perpendicular distance is R and 45. So R into sine 45 into the mass m, and the velocity that is just towards the negative y-axis, it is equal to v minus of, okay, this one. So when we want, either we can calculate the dot product of R cross V and m. So when we will calculate, that is equal to m into R V into sine of theta, and usually we are getting this value as 135. Okay, so we will get that angular momentum will be equal to minus of m into V upon root 2 into R along K. Okay, so this one. So it would be just out of the plane. Now for this case, right, it is following the same concept. Means when it is going downward, the angular momentum would be outward. Same for this, because this would be the perpendicular distance. Velocity is going along the x-axis, that should be vi, and it is just a perpendicular distance. Now it would be equal to, for this part L A to B, it would be just m into v upon root 2 for this part, that is equal to minus of k. Same thing, okay, it would be same. Now we want to calculate for B to C. So the perpendicular distance is what? When total distance is B2 plus A, that is equal to BA, and this distance is this one. So for this part B to C, so we would like to know that momentum for B to C, it would be equal to m into V. The net distance, it would be equal to R by root 2, that is perpendicular distance. So it would be A plus R by root 2. So A plus R by root 2 into sine of this value. So already we calculated, and its direction is around positive k cap, rather to sine equal to sine. So that's why we can say option C is the correct choice over here, and also the option A is correct choice. Now option D, if we want to calculate angular momentum from C to A, C to D. So that is equal to m into v. So it would be equal to a plus r by root 2. A plus r by root 2. Okay, so m into v. So this one. So when for this case we will take it positive. So in this problem we are getting option 1 and option 3 are correct choices. And formula we use, that is equal to m(r) sine of theta, and we can find out the dot product of position vector with the velocity. So it is negative, both are positive. And that matches with option 1 and 3 over here. Now question 36. In question 36 we are given this choose the incorrect statement. Also choose the correct statement. This question is taken from the semiconductor devices and in the communication physics basically. Now 4 options. In frequency modulation, the amplitude of the higher frequency carrier wave is made to vary in proportion to the frequency of the audio signal. Second part, in amplitude modulation, the amplitude of the higher carrier wave is made to vary in proportion to the amplitude of audio signal. Third, in amplitude modulation, the frequency of the higher frequency carrier wave is made to vary in proportion to the amplitude of the audio signal and impedance. So actually we are given 2 parts, amplitude modulation and frequency modulation. Usually in amplitude modulation, we know that when in amplitude modulation, so this kind of arrangement where the amplitude is getting varied with the frequency. Carrier signal is what? Means the frequency or the signal generated by the telephone, and whatever we are speaking, it is a massive signal. Massive signal superimposed on the carrier signal getting a net broadband frequency. Now we are talking about frequency modulation and or either amplitude modulation. So usually we found that in amplitude modulation, the amplitude of the higher frequency carrier is made to vary in proportion to the amplitude. So of course we can say the frequency of higher amplitude wave is getting varied with the amplitude. Usually we can see this over here. But in case of frequency modulation, like this, frequency modulation, it can be of different. So of course option first 3 and 4 are wrong, and only the option that is correct in amplitude is getting varied with the frequency in amplitude modulation. Hence option 2 is the correct choice. Now we solve these questions and we are approaching towards the next question. Question number 37. So question 37 is in an experiment for the determination of refractive index of glass or prism, in which angle of incident, angle of deviation, angle of prism, and all these data are given. So we have to find out the correct options for the refractive index, for which the refractive index is maximum. Now I would like to write here, in an experiment for determination of refractive index of glass or prism for incident and deviation plot, it was found that a ray incident at angle 35 degree. So in question 37, angle of incident it is given as 35 degree. Now carrier suffers a deviation of 40 degree. So deviation is given as 40 degree. After that it emerges an angle E is equal to 79 degree. Now in this case, which of the following is closest to the maximum possible value of refractive index? Usually, in case of minimum refractive index, when we draw a graph between I and L, usually we are getting the value of I for which this is minimum. Means deviation is considered to be minimum. Now, deviation is considered to be minimum. Okay, so now we can say that we have to find out the condition. This is possible only when angle of incidence is equal to angle of emergence. Okay, and R1 plus R2 should be equal to angle of prism for the minimum deviations. As we increase the value of incident, definitely there would be change in this. So definitely for the minimum deviation, angle of incident should be equal to angle of emergence, but which is not equal. In this case, I is not equal to E for the minimum deviation. So in this question they are talking about for the maximum deviation, okay, for maximum value of refractive index. So what? Maximum value of refractive index can carry the greater value of greater standard minimum deviation. So deviation angle of this one in this case. So we can put the value that is I 35, del 40, E is equal to 79 and I is equal to E. So we would like to write the conditions for this, that is I plus E should be equal to A plus del. First of all, we would like to calculate the angle of prism. A is equal to I plus E minus del. So that is equal to 35 plus E 79 minus 40. Solving this one, we are getting around 74 degree. Now we want to find out R1 plus R2 should be equal to A, and for this is equal to 74. Minimum deviation is possible when R1 is equal to R2. So what we can write this? Okay, if R1 or R2, so we can say mu is equal to sine of A plus del M by 2 upon sine of R by 2. Okay, so if R1 is equal to R2, if R1 is equal to R2, we can say R is equal to 74 by 2. Usually put this value in the main equation, we are getting this is equal to 1.5. It's equal to 1.5, for which the angle of minimum deviation is 40 degree. Now, they want to calculate the maximum possible value of refractive index. If there is a change in the value of refractive index, definitely there will be change in this value. So always we need to understand the things that can be. So minimum deviation can be possible when this is equal to the 40 degree angle of this given data. So easily we can say, well, we solve this value, mu can be less than 1.5 because minimum deviation is possible for which the less than is 40, because when we put all these data over here, we get mu is equal to 1.5. Usually we know that for R1 equal to R2, we are getting angle of minimum deviation, for which the refractive index mu will be less than 1.5 for this. So mu can be equal to or maximum to 1.5, and that is closest to the option 2. Hence option 2 is the correct choice.